Lesson 1-7 is on writing equations. The main idea today is actually to be able to write an algebraic equation. Remember, an equation has an equal sign. Algebraic is probably a number sentence or a mathematical sentence that we're going to be using some variables. The vocabulary word is equation. Well, we talked earlier in the year the difference between an equation and an expression. An equation is basically a mathematical sentence containing an equal sign. So we will have an equal sign here. Few steps to writing equations, and actually they are on your guided notes. The first thing when you write an equation, don't get frustrated with this. You might have to read the problem 4 or 5 times to be able to actually write the equation out. You will need to write it or read it numerous times. I read it numerous times to make sure I have things down correctly. But after you read it numerous times, it's easiest if you actually write things out in words first. Secondly, after you write things out in words, you want to define a variable. And basically what you're doing is after you write things out in words, you look at it and you determine, alright, what is it that I need to know or what is unknown? And then come up with a variable for that unknown quantity. And then lastly is to actually take your verbal model in words and use your variables and write it into an algebraic equation. So those are the 3 steps that you'll want to take here. And I'll show you how to use those steps. First example that I have here is, again, we're going to write it in words. Then we'll determine a variable, and then we'll write the equation. 1. Did you know the number of pounds of insects a bat can eat is 2.5 times its own weight? Again, you might need to reread it again. The number of pounds of insects a bat can eat is 2.5 times its own weight. In words, basically you're using your sentence here and you're just writing it out in your own words. So the first part it says is the number. Let me use another color than red here. Number of pounds of insects equals 2.5 times the bat's weight. So maybe you need to reread here. It says the number of pounds of insect a bat can eat is 2.5 times its own weight. So we know that the number of pounds of insects equals 2.5 times the bat's weight. So in this problem, what is unknown? Well, we don't know the number of pounds of insects. That's unknown. So maybe I'm going to use for a variable n for number, and that represents number of pounds of insects. That's unknown. Another piece that is unknown is, well, the bat's weight. We don't know what the bat's weight it is. Yes, we know it's 2.5 times, but we don't know the bat's weight. So, and that varies from bat to bat. So we will have the bat's weight here is unknown. So I'll use B for bat's weight. Now I have rewritten my problem. I've determined my variables. Now I can go ahead and write an equation. So we know the number of pounds is n. Okay, number of pounds of insects equals 2.5 times the bat's weight. Well, 2.5 times the bat's weight is B. When you have a number next to a letter, it means to multiply. So 2.5 B. That is your equation. Inspector Clouseau would like to buy some hamburgers at the local burger joint. The going rate is $1.25 per burger. To wash down the deliciousness, he purchases a large soda for $1.59. What would we like to know here, or what is some information that we know? Well, the rate is $1.25 per burger, so that determines how many hamburgers Inspector Clouseau gets. And he also purchases a large soda. A is singular. So the words here, what are we trying to find out? Well, we know that we are trying to find out his total bill from here. So he wants to figure out how much money he spends. His total bill equals the number of burgers, right? Burgers that he gets at $1.25. Okay, it's $1.25 per burger. Plus his large soda. Now we need to figure out the unknown quantities here. Unknown, we don't know his total bill. So I'm going to say that maybe T will represent his total bill. We don't know the number of hamburgers he gets, so I'll say H equals number of hamburgers and remember, another piece of information is at $1.25 because it's $1.25 per burger. So using our information here, we need to go ahead and write an equation. We know that we are trying to find out T, our total bill. Our total bill reflects the amount of hamburgers we have. We know it is 1.25 $1.25 per H. So if we had 5 hamburgers, you could substitute 5 in for H. $1.25 times H, which would be 5, you could figure out your total bill. You also need to include the $1.59 for his purchase of soda. So his large soda, which it says right here, is $1.59. So you need to add that to his bill. And that is our equation for example 2. Here's a little video for you if you don't know who Inspector Clouseau is.
I would like to buy a hamburger.
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 No. Let's break it down. I would
Weird.
like to
Toi.
buy a hamburger. Hamburger. I would like to buy a hamburger.
I would like to buy a hamburger.
It's not hamburger, hamburger.
I'm not saying hamburger. I said I would like to buy a hamburger.
I would like to buy a hamburger.
I would like to buy the hamburger.
Hamburger.
I would like to buy a hamburger.
Maybe we should stop.
We don't quit. We do not quit. Again.
I would like to buy a hamburger.
I would like to buy a hamburger.
I would like to buy a hamburger.
I would like to buy the burger.
I would like to buy a hamburger.
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 The burger.
Our last example, example 3, submarine dove 75 feet below its original depth. If the submarine's new depth is negative 600 feet, what was its original depth? Write an equation to solve the problem. So again, I'm going to write it out here in words that a submarine dove 75 feet below its original depth. So original depth Original depth from the original depth, the submarine, the sub, dove 75 feet, equaling its new depth, right? Its new depth, which was negative 600 feet. So just kind of rewriting it in your own words. Now from that, we need to go ahead and determine a variable. So what is the unknown? Well, we don't know the original depth. So I'm going to say D equals original depth. We know from that original depth that it dove 75 feet, equaling its new depth, which we know is negative 600. So we know the other piece of the information. So now to write our equation, here's our original depth that we start with, D. From that depth, your submarine dove 75 feet. When it dives, it decreases. So the sea level, we would drop minus 75 feet, right? We're jumping off 75 feet when we dive. So little keywords that you need to take into consideration also on your assignment. And that is going to equal our new depth, which was negative 600. There is our equation. Actually, good example here, reason being is this last summer here. If you look down here at the bottom, I don't know, I can probably share some of this here, but some pictures from the World Submarine Racing Championship that I attended over the summer. They're pretty cool pictures here, so I'll show you some of the pictures that I was at this summer for the Submarine Racing Championship. Here they are. So, yep, there's the racing right there, the submarines racing. Pretty cool pictures. They are submarines, remember. So, I guess I didn't really know what would you guys expect to see, right? They're submarines, but they're pretty sweet pics. This will conclude our lesson here on 1-7 writing equations.